Hi there, folks. Today we're looking at midpoint and distance in the coordinate plane. We've talked about the midpoint of a segment being the center of it, being the middle of it. It breaks the segment into two congruent pieces. But from the perspective of the coordinate plane, so kind of going back a little bit to that algebra type of stuff, the midpoint is equal distance from the two endpoints, all right? So now instead of talking about it in terms of a segment, we're talking about it in terms of the coordinate plane, looking at endpoints and finding the point that's in the middle. So midpoint and distance. If I look at something like this guy, I want to find the midpoint and distance of each. So if it asks me to find the midpoint and distance from x and y, I'm actually going to find the distance first. And so if I look to the distance from x to y, I can simply count the distance and say, oh, to go from x to y, it's 1, 2, 3, 4, 5, 6, 7, 8 units away. So I would just say that the distance equals 8. All right. And now the midpoint means I go kind of halfway. I go to the middle of those two. So instead of counting 8 units, I would count 4 units. 1, 2, 3, 4, which means my midpoint is right here, and that's the order pair -4, 1. All right. And the midpoint, I'm going to use a capital M for midpoint. Remember, lowercase m is slope, so capital M is going to be our midpoint. All right. And that's it. I'm just counting to that center. All right. If I ask for the distance from x to z, the problem is, unlike the first example, I can't count diagonally. All right. If I go diagonally across a room, it's a longer distance than if I go across the room perpendicularly. Okay. If I go straight across a room, it's a shorter distance than if I go diagonal. So I can't count diagonally. It doesn't give me the appropriate number of units. So I have to count in directions that I'm able to count. So like here, to get from x to y, it was down 8 units, right? And now to get from y to z, it's over, well, let's see, 1, 2, 3, 4, 5, 6 units. So it was down 8 over 6. And see, I can count in those directions. So the question now is, what is the distance if I travel diagonally? All right. And hopefully you see here that what I've done is I've drawn a right triangle. And the one thing that we know about right triangles from probably previous math courses is the good old Pythagorean Theorem, which I can do here. All right. I can say, hey, I want to find this missing side. I'll call it x. So then I would do a squared plus b squared equals c squared. In this case, 8 squared plus 6 squared equals x squared. All right. And yeah, I could have used C there or A or B. It doesn't matter. All right. And so here I do my Pythagorean theorem. That's a 64 plus a 36. So now I've got 100 equals the x squared. And once again, if I remember from algebra, I take the square root of each side. Now from an algebra 2 perspective, you probably recognize this as x equals plus or minus the square root of 100, because remember, whenever you take the square root of each side of an equation, you need a plus or minus. So our answer in algebra 2 would be plus or minus that 10. But for geometry purposes, we're just going to say 10 here. And the reason we're going to say 10 is because, well, we're talking about a distance. We don't measure distance in terms of negative, all right? Until maybe you get to physics and you're talking about direction, all right? Now, the question is midpoint. All right, and if you think about the first example, x and y, I just counted halfway. Well, I'm going to do the same thing between x and z, but remember, to get from x to z, I counted in 2 different directions. So now to find the midpoint, I'm going to count halfway in 2 different directions. So instead of going down 8 and over 6, I'm going to count down 4 and over 3. All right, I go halfway for each. So down 4 over 1, 2, 3 drops me right here, right in the center of that. And you can see visually that it's the middle. All right. So by counting halfway down and halfway over, I get my midpoint. And so for this one, the midpoint, I'm not pleased with that M. I feel like that's not up to my standards. So the midpoint here, I'm going to say midpoint is -1, 1. Okay. So again, the distance, I either count the distance, or if I can't count, if it's diagonal, I count the directions that I can. I do my Pythagorean theorem. And then the midpoint, I count halfway. All right, and if I counted in two different directions, if it was one where it was diagonal, I count halfway down and halfway over. All right. If we don't have a graph, we have some formulas that we can use to find the midpoint. The midpoint essentially is like the average. That's how I remember the formula. It's the average of the 2 points. So I take the average of the x values, and I take the average of the y values. And since I'm finding the middle of 2 points, well, the average just means add them together and divide by how many you have. If I have 2 points, I add the 2 things together and divide by 2. All right, same thing with the y values. I add the 2 y values together and divide by 2. I'm finding the average. All right. The distance formula is this. It's distance equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And different textbooks will have that written differently. Some of them will say x sub 1 minus x sub 2 and y sub 1 minus y sub 2. It doesn't matter, all right? It'll give you the same answer either way. I write it this way for a very specific reason, because it mimics my slope formula where we did x sub 2 minus x sub 1 and y sub 2 minus y sub 1. All right. And so I do that so that it's kind of reminiscent of some of those pieces. And really, those things are kind of related. When you think about slope and subtracting the x's, we were finding like the distance between the x's. And then when we subtract the y's, we were finding the distance between the y's. We're doing the same thing here. We're finding the distance between the x's, the distance between the y's. Essentially, the distance formula is just a fancy way of writing the Pythagorean theorem where it's already solved for the hypotenuse, okay? See, the subtraction between x gives us the distance for the x values, which is like our a value, right? And the subtracting the y's is like our b value of that triangle. Here, ax squared plus a squared plus b squared equals c squared. Well, then I take the square root when I go to solve. Okay, and so hopefully you can kind of see those elements involved there. But I relate it back to slope, because remember, slope, we used to not do x sub 2 minus x sub 1. Maybe at some point you learned how to do change in x, all right, where you did change in y over change in x. You can do the same thing here, okay? And so if you want to do your distance formula as change in x squared plus change in y squared, you may do that as well, okay? And I'll kind of go through those and just give you some of the options that we have, all right? For example, if I look at something like this guy, if I want the midpoint and distance, I'll start with midpoint because that's the easiest one. The midpoint is just the average here. So, and you can put m equals, or you can just put the m next to it. I'm fine with that. So here, it's the average of the x's. So I do 7 plus 3 divided by 2. And then for the y's, I do the average, 5 plus 1 divided by 2. And so here, 7 plus 3 is a 10, divided by 2 is a 5. 5 plus 1 is a 3 divided by 2. 5 plus 1 is a 6 divided by 2 is a 3. Got a little ahead of myself there. And so there's my midpoint, all right? Distance, I can use my distance formula. So here we go. I subtract the x values. So 3 minus 7 squared plus 1 minus 5 squared. And it doesn't matter what order you do those in. If you did 7 minus 3 instead and 5 minus 1 instead, that's okay. All right? You'll end up with the same result either way. So now here, that's 3 minus 7 is a negative 4. When I square that, sorry, my 2 doesn't look like a 2. It looked like a 7 up there. When I square that, it gives me a 16. Here, that's a negative 4, and when I square that, it gives me, once again, a 16. And so now the distance equals the square root of 32, which, of course, I remember how to simplify square roots. 32 is 16 times 2. The square root of 16 is a 4. The 2 is still trapped. Okay, and if your head just spun in a circle there, you might have to go review some of that stuff from Algebra 1 and Algebra 2, all right? Or you might have to take that off to the side and do your factor tree and that kind of stuff, all right? And now here's the thing. Sometimes we'll leave it in radical form, and other times we'll plug that into our calculator. For now, we'll just leave it in radical form. If we're doing a word problem where it's asking us for an actual distance in a real world context, we'd want to plug that into a calculator, okay? But a lot of times we want to leave it in terms of square root so that if we're going to use that for other measurements, we have a very accurate depiction of that, okay? The other option here, if you think about it in change in y or change in x, and maybe I'll do that with the next example. Plugging things into a formula should be easy enough. If we look at the next example, midpoint is easy enough that most of us can probably do it in our heads. Ready? Well, let's find the average of the x's. 8 and a -4 give me a +4, divided by 2 is a 2. All right? And if you need to write down the formula and do all that stuff, that's fine. It's always okay to show extra work. Don't do too much in your heads, all right? We're probably at the point that some of this easier stuff you probably can do in your heads. You've been doing it for a while, okay? The next one, adding the y's together and dividing. So -2 plus 0 is a -2, divided by 2 is a -1. See, it's just finding the average of those two things. And really, if you want to think about the 8 and the -4 in a number line, think about where the halfway mark is, okay? The halfway mark is at 2, all right? It's 6 units away from 8. It's 6 units away from -4, all right? Same thing with the -1. In terms of distance, let me do it this way. If I think of it in terms of change in y and change in x, like if you looked at from an 8 to a -4, the change from 8 to -4, you have to move 12 units, all right? And when we did that with slope, we probably called it a -12. Here, it really doesn't matter, but that's like if we were kind of drawing a triangle, and I always just kind of take it off the side, that means that this right here is 12, all right? Just think of it in terms of the positive, it makes it really easy. Same thing with these guys, from -2 to 0, that's 2 units. Think of it in terms of distance, it makes this a 2. And now it's my Pythagorean theorem. 2 squared plus 12 squared equals c squared, okay? In terms of our formula, it just replaces that subtraction with this. There it is, 12 squared plus 2 squared, okay? And if you do the full all-out formula, that's okay, all right? You might get a -12 instead of a +12 or a -2 instead of +2. It doesn't matter because we're squaring it. But we end up with 144 plus a 4. And again, this is the same thing that would happen if I had done my Pythagorean theorem. See, the Pythagorean theorem off to the side here would be 12 squared plus 2 squared equals c squared. And now look, I'm doing the same thing. 144 plus the 4 equals c squared. 148. And guess what? I'm going to take the square root of each side. Okay? And so you just kind of have to find out what works best for you. I almost never, ever use the actual distance formula. Okay? I typically go the route of the Pythagorean theorem because, frankly, I can. All right? And now, once again, I can simplify this thing. There's a 4 that divides evenly into that thing. The square root of 4, so I should probably start with the 148. It's 4 times 37. Square root of 4 is a 2, and the 37 is still trapped. Again, if you need a refresher on some of those things, look back at some of the algebra stuff, that's okay. Or if you need to take it off to the side, do your factor tree, okay? So again, use the formula or think about in terms of distance, use your Pythagorean theorem. That's how we can find the distance, all right? So here are some more complicated examples. Given endpoint -2, and midpoint 3, -1, find the other endpoint. And so probably one of the easiest ways to do this is you could think about it in terms of the formula. You could also graph this thing, would be a really easy way to do it if you have some graph paper handy. So if you think about the formula was I added the x's together and divided by 2, all right? And see, for this particular example, that would give me the x value for the midpoint. And so think about what I know here. I know one of the x values for the endpoint. It's -2. And I know what this is supposed to equal. It's supposed to equal a +3. And so now I can solve this thing. This is a proportion. If you remember solving these in Algebra 1, you cross multiply. So you get an x -2. I just rewrote that a little bit, equals a 6. And now I add that 2 to each side and I get an 8. Okay, you can kind of do the same thing with the y values. You have one of the y values as 5, plus the other y value divided by 2 should equal the y value for the midpoint, which is -1. And once again, I could solve by cross multiplying. So I've got y plus 5 equals a -2. I subtract that 5 from each side and I get a -7. Okay, and so from here, basically what I have is, hey, this guy right here is 8, -7. But again, That's going that completely algebra-based kind of method here. In all honesty, it's probably easier, all right, to kind of go with a more conceptual version of this thing, all right? If you were to kind of think about the graph, or on this one, you could even just think of it this way. To get from the end point to the midpoint, the x value had to go up 5 units. So to get from the midpoint to the next endpoint, guess what? I have to go up another 5 units, which would bring me to an 8. And see how I kind of did that in my head? If you look at the y values, it was a 5, and now it's a -1. It went down 6 units. So to get to the next endpoint, I have to go down another 6 units. So if I was a -1, I went down another 6 units. That's a -7. And so hopefully you can kind of get that idea. And really, all I'm doing there is I'm thinking about the graph in my head and how this thing works. And if you kind of think about it from the perspective of getting one point to the next, -2, 5 is up here somewhere. 3, -1 is down here somewhere. We're essentially counting down to get to this guy and over to get to this guy. And then I count down and over the same amount to get to the thing I'm looking for. Okay? And so there's a lot of different ways that you can approach this. The formula is just one of them. Okay? If I look at the next one, same kind of thing. I've got one of the endpoints and I've got the midpoint. All right? Out of curiosity, I'll jump right to the end. All right? So for those really high-level thinkers, if you can handle this, all right, man, you can really save yourself some work. So to get from endpoint to midpoint, to get from 1 to 4, I went up 3 right here. All right, I went up 3 units. So to get to the next endpoint from the midpoint, I have to go up another 3 units. So if I was at 4, I went up another 3. That's a 7. All right. Same thing here. If I was here at 3 to -2, that's down 5 units. Well, keep going. I got to go down another 5 units. That's a -7. But now let's check it. I can check it algebraically, or I could graph this thing and count from one point to the next and use the same amount of counting to get to the next guy, okay? And so again, if I kind of think of it this way, I say, hey, the x value plus the x value I don't know divided by 2 should equal the x value from the midpoint, 4. And now I could cross multiply. Here we go again. X plus 1 equals 8. Subtract the 1 and I get a 7. Huh, shocking, right? And I could do the same thing with y. I said, hey, I got the first y value plus the y value that I don't know about divided by 2 should equal the y value for the midpoint. And so now I cross multiply. Oh, sorry, it's got to be in blue, right? I think we all feel that way. Y plus 3 equals a -4. And now I subtract that 3 from each side and I get a -7. All right? And the shocking result is that I got the same thing that I did with very little work going the other way, okay? And so that idea of visualization in geometry can be really helpful, because if you visualize what's happening on the graph, counting from one point to the next, continue counting from one point to the next, and you're there without doing any algebra, okay? How about something like this guy? It says, given the midpoint is 6, 3, and a segment has a length of 20, find a pair of possible endpoints. And there's multiple answers that we could have here. The easiest way to approach this problem, if you have 6, 3 in the middle, is to kind of move up and down or left and right to make a vertical or a horizontal line. And so if the length of this thing is 20, that means you have to go 10 in each direction, right? So for something like this, if the midpoint is at 6, 3, well, to go up and down, I would just change the y value. So I could do 6, 13 as one of my endpoints. If I go down, it would be 6, -7. Okay, so it's that idea of just moving. And now you could count this thing out from -7 to +13. It's 20 units, okay? And so all I've done is I've kind of visualized, I've thought about the graph of this thing and said, hey, 6, 3 is up here. Well, if I go up 10 units and down 10 units, there's a length of 20, and here's the endpoints that I have, 6, 13, and 6, -7, okay? I could do the same thing, visualizing it, but let's go horizontally this time. Let's go left and right. So let's increase or decrease the 6 by 10 this time. All right, so if I went up 10 units, it would be 16.3. And then my other endpoint, let's go down now. That would be negative 4.3. And again, visually, when I'm thinking about this on the graph, 6.3 is here. So I went this way 10 and that way 10 and just said, hey, these are where those points are. Now I have a length of 20, but I have that 6.3 in the middle, okay? And so it's, again, kind of thinking outside the box and not just being locked into doing algebra all the time, okay? The follow-up question to this is, what if we didn't want it to be vertical or horizontal? What if I wanted kind of a diagonal line? And again, the idea here is to kind of conceptualize this on a graph, all right? And so if we kind of thought about this for a second, this one's kind of tricky, and it's kind of going to test our knowledge of right triangles here. But 6.3, let's say that's here, all right? So now I'm looking for an endpoint that's up here somewhere and an endpoint that's down here somewhere. But again, I still have to go 10 units, all right? And I might not know how to do that, so I have to think about a right triangle that kind of going over and up, that this would give me a 10. And so this is probably going to be really tough for some of you, but maybe some of you are already thinking, wait, I know a right triangle because we did one earlier today where it did like 6 and 8 or something like that. And see, that's one where the Pythagorean theorem would work out to give me a length of 10. Same thing here going the other way. To give me a length of 10, be a 6 and an 8. And so really from 6.3, if I increased the x, again, let me write the midpoint as 6.3. But essentially it's saying, hey, increase the x by 6 or decrease it by 6. So if I increased by 6, that would be 12. For the next one, it would be 0. And then the y, I'm going up or down 8. So if I increased it by 8, it would be 11. If I decreased it by 8, that would be a negative 5. So this would be one particular option. But again, it's trying to think outside the box, all right, and kind of apply some of those things that we've done in the past, like the Pythagorean theorem, but doing it from a more conceptual standpoint, all right? Thinking outside the box to try to figure out where could I put these. And again, that's not the only answer. I could have gone left and right 8 and up and down 6, okay? Or I could have used some kind of decimals in here that might work out. All right. So again, there's multiple answers here, but we want to start to think outside the box and think more conceptually and visually about these things instead of algebraically. Okay?